Jai Bharat to all students. In last two lecture we have discussed about two different types of sequence, arithmetic sequence and geometric sequence. In both sequence we have discussed about its definition and how to write geometric and arithmetic sequence and what rules it follow. Okay, rules of geometric and arithmetic sequence is related example if we want to find nth term for arithmetic or geometric sequence. Then also we have discussed about summation of n terms of geometric and arithmetic sequence. Okay, and its related example. Okay, so in today's lecture we will discuss about partial sum. Means if it is an infinite sequence, we will sum about finite sequence like 4 term, 5 term, 6 term. Okay, it's basically a sigma. Okay, but we will discuss its different types of sigma property and its related example. Okay, we all know basic property or basic definition of sigma or how to use sigma in summation. Okay, so here we will discuss about sigma, different types of sigma property in deep. Okay, and its related example. Okay. Okay, a partial sum is a sum of part of the sequence. Okay, if it is a whole sequence, then it is a one parts of summation of one part. Okay, partial sum, not whole sequence summation of whole sequence. Okay, but number of sequence. Okay, summation. Okay, here you can see that this is a sequence of even number. Okay, if it is infinite, but partial sum is a if let's say example we take first 4 term, we also take first 5 term. Okay, countable sequence, countable terms. Okay, which is called partial sum. So if we want to find first 4 terms of the sequence and addition of partial sum, so it will become 20. Okay. We all know sequence. Okay, so basically sum of infinite terms is infinite series, but partial sum is also called finite series. Here 2 4 6 8 is countable, so it is also called finite series also. Okay, finite sequence. Okay, and sigma, partial sum are often written using sigma to mean add them all up. Okay, it's called symbol, it's called sigma. Okay. But what we have to add? Okay, some things up, but what things? Okay, so we whatever is we have to add, we can add after the sigma symbol. Okay, so here sigma and n, so we have to sum n number. Okay, but how do we use, what is the value of n? Okay, so value are shown below and above the sigma. We all know how to write up like this sigma. Okay, so it says n goes from 1 to 4, which is 1 2 3 4, and summation of these 4 terms. Okay. So this will become 1 2 3 and 4 terms is equal to 10. So okay, so this is how we use sigma. Okay, where to start, where to end, and what to sum. This is a basic of sigma. Okay, now let's say we have to add more powerful things. Okay, okay, so this is n is equal to 1 to 4, but here they have write n square, so we can use 1. We have to use n is equal to 1 to 4, so 1 square, 2 square, 3 square and 4 square, so its summation is equal to 30. Okay, We can also take 2n plus 1 also. Okay, n is equal to 1 to 4, 2n plus 1. We can take anything in what to here sum part. Okay, or any value 1 to 4, 1 to 5, 6. Okay, we also take here uh, they have take as a I. Okay, so here we use I and sum of the I into I plus 1. Okay, so we can also take I into I plus 1. So here what will become? I is equal to 1 to 3. Here we can take n and its sum also take as a n, but here we use I. Okay, no problem, you can take anything A, B, C, P. Okay, so here if we put I is equal to 1, first term will become 1 into 2, second term is become 2 into 3, and third term will become 3 into 4. Here we have to only use three term, so summation of 3 term will become 20. Okay, we can use these types of summation also. Okay, so now let's say talk about property. Okay, multiplying by a constant. Okay, so let's say we have something we want to sum up. Let's call is ak. Okay, ak could be k square or k minus anything. Okay, here also k upon k plus 1. Okay, we have to only denote this as a k. Okay, and c is the some constant value, like anything in the r, 2, 1 by 2, minus 2 by 5. Okay, so if it is a k is equal to m to n and we have to add c ak, here you can see that c is the constant value. Okay, so if you do not have to add all the value and multiply with c, you can take like this. Okay, common out constant value and add other value. Okay, if it is like say phi n is equal to 1 to 3. Okay, so first term will become 5 3 15. Okay, second 5 or 10 and 15. Okay, you can add also like this, or you can common out 5 and make n is equal to 1 to 3 and here n. Okay, also. Okay, so it will become easy in multiplication. Okay, if we common out the constant value. Okay, so this is the property of summation, first property. Okay, like this. Okay, they have given example also, sigma k is equal to m to n 6k square. So we can common out 6 and only we have to add this k square also. Okay, it will become much easier if we common out 6. Okay, and after that we can multiply with the 6. Okay, second property is adding or subtracting property. Okay, if it is in bracket sigma k is equal to m to n ak plus bk, so we can common out. Okay, or sorry, we can multiply with both the terms. Okay, so it is also is equal to sigma k is equal to m to n ak plus sigma k is equal to m to n bk. Okay, like in bracket, if we here is a 2, here is a x plus y. Okay, if we want to add 2 in bracket, so 2 will multiply with the both the terms. Okay, so it will become 2x plus 10, like this. This property is also contain sigma property, second property. Okay, so here I have given example k plus k square. So we can differently sum and then after we can add them. Okay, so it's going to be easier to do the two sum and then add them at the end. Okay, also it's work from subtraction. Okay, now let's say some useful shortcuts in the sigma property. Okay, we sigma k is equal to 1 to n. Here they have only given one constant. Okay, So 1 plus 1 plus 1 plus we are what terms n times. Okay, here they have given n. So if we, so what will become summation? Is it equals n, summing 1 equals n. Okay, now second is k is equal to 1 to n. Here c is our constant. Okay, we can take c out. Okay, so it will become sigma k is equal to 1 to n and 1. Okay, so 1 we all know it will become n, and here c is, so it is n c. Okay, now sigma k is equal to 1 to n k. This is become 1 plus 2 plus 3 plus 4 plus. Okay, now we all know what is the summation of all the natural number. Okay, it is n into n plus 1 by 2. Okay, it is same. Okay, so in exam, if we can come up with this sigma, we can write like this: n into n plus 1 by 2. Okay, here if it is a summation of all the square value. Okay, so we all know equation of summation of square value. It is n into n plus 1 2n plus 1 divided by 6. Okay, square summation of all the square value. Also there is a formula for summation of the all the cube number. Okay, natural number 1 to n cube. Okay, so it will n into n plus 1 divided by 2 whole square. Here you can see that this is the same as a sigma k is equal to 1 to n k, all natural number. Okay, so we can also write like this: k cube is equal to sigma k is equal to 1 to n k is whole square. Okay, right, we can also write like this. Okay, this is a summation of all odd number. We have seen this rule in the first lecture, 2k minus 1. This is a odd number summation, so it will become n square. You have to remember this all the formula. Okay, it will use in the example of partial sum or any sequence in series. Okay, or also this k square and k cube, this formula also used in different chapter or different mathematics subject also. Okay, so all the formula you have to remember. Okay, now let's start with the example of partial sum. The first is you sell concrete blocks for landscaping. Okay, a customer say they will buy the entire pyramid of blocks you keep out from front. Okay, shopper is keep out like this. Okay, pyramid concrete ball they have put up like pyramid. Okay, so customer have to they will buy the entire pyramid of blocks. Okay, the stake is 14 block high. Okay, 1 2 3 and 14 blocks high. Okay, so we have to calculate how many blocks are in there. Okay, so how do we calculate? Okay, so here you can, if we see from the top, you can see that there is a square. Okay, this is the first block. Okay, second layer will become how many blocks? Here 1 2 3 4 5 6 7 and 8. Okay, second layer and 9. Okay, square. Okay, so each layer is a square. Okay, so we can calculate like it. First layer is a 1 square means 1 block. Second layer is 2 square. Okay, now third layer is 3 square. Okay, it is a square if we see from the top. Okay, and plus this is a 14 block size, so our sequences will become up to 14 square. Okay, so we have to add how many blocks. Okay, so we can easily write summation partial sum. Okay, k is equal to 1 to 14 and it is a square, so it is k square, and we can use our previous formula of all the square number, addition of all the square number. So what is the formula? N plus 1, 2n plus 1 divided by 6. Okay, we only have to put n or k is equal to 1 to 14, so k is equal to 14. Okay, from calculation we can get the answer, and we can say that there are 1015 blocks. Okay, concrete blocks. This is a easy formula for easy one example. Now let's say we complicated example. Okay, the customer also wants a better price. Okay, better price. How? Okay, the customer says the blocks on the outside of the pyramid should be cheaper as they need cleaning. Okay, here you can see that this is a first block, first layer. Okay, sorry, this is second layer. They this is all are outer side. Okay, so from the air pollution, this block needs to repairing. Okay, cleaning. Okay, so customer says out all the outside blocks should be cheaper, and from you can take inside block as a it is a price. Okay, so you agree to $7 for outer blocks and $11 for inner blocks. Okay, so we have to calculate what is the total cost for 14 blocks high. Okay, so now okay, here we have some equation for the calculate of number of outer blocks and inner block in the 14 stack. Okay, so for calculation of outer blocks is equal to 4 into size minus 1. So what is the size? If it is a this is a what is a second layer, yes, then it will become third layer. Okay, so this is a valid for not valid for first layer, because first layer is only one value. Okay, so it is valid for 2 layer and above, more than 2 layer. Okay, so if you want to calculate what is the outer block in second layer, okay, so what will become size is second layer means size is 2. Okay, 4 into size 2 minus 1, 4 into 2 minus 1, so it will become 4, and inner block is 2 sorry 3 second layer, sorry this is for third layer. Okay, so this is equation of the calculation of outer blocks and inner block. Okay, so now what is the cost of outer block? $7 into 4 size minus 1, and what is the cost? $11 into size minus 2. Okay, so now we have to all the add all the layer together. Okay, except first we for just now we have not included first layer. Okay, which is a first only one block. Okay, so now here start from the second layer. I is equal to 2 to 14. Okay, $7 into 4 I minus 1 plus $11 I minus 2 whole square. Okay, now let's add some property, so can it will become much more easier for the calculation. Okay, so we can apply additional property. Okay, we separate out both the term. Okay, also we apply second property, multiplying by constant property. $7 is a constant, $11 is also constant, so we can common out. Okay, so now here you can see that this sigma is start from I is equal to t. Okay, so we cannot use the previous our shortcut this. Okay, here you can see that it is also always start from the 1, then after we can use this formula. Okay, but here we have I is equal to 2, it is start from I is equal to 2, so we cannot use the our shortcut. Okay, so how do we calculate? Okay, So let's say we invent new variable. Let's say j is equal to I minus 1. I minus 1. Okay. And our for this we can say k is equal to I minus 2. Okay. I minus 2. So what will become if here I is equal to 2? If we use j is equal to I minus 1, so I minus 1 is equal to 1, so it is a j, so it will become j is equal to 1. Okay, here the second term, for the second term I is equal to 2 and we have to use k is equal to I minus 2. So if 2 will bring the from the left hand side of the is equal to I minus 2 is equal to 0, so k is equal to 0. But if it is a k is equal to 0 here second term, okay, and if we want a square, so what will 0 square will become 0, always 0 if it will start from the 0. So we can start from the also take k is equal to 1. Summation will become not effect if we use k is equal to 0. So we can start with the k is equal to 1. So here you can see that both the sigma properties start with the 1. We can use our basic shortcut formula. Here it is a j, so we can use natural number, and it is a all the summation of all the square number. We can use the its equation. Okay, so after calculation we have now the answer of all the cost. Okay, but remain we have not calculated first layer. Okay, so this is formula is for the second layer, I is equal to 2. We have not calculated first layer, but first layer is a only one block and it is a outer side, so we can sell with the plus $7. Okay, so you have to add plus $7. Okay, so this is our answer. So this example is much more difficult to, okay, but after some time it will become easy. So with that types of equation we can use the partial sum and sigma property also. Okay, now here is your assignment question. What is the value of sigma k is equal to 1 to 10 k into k minus 1 k plus 1? Okay, so how do we calculate? First of all, multiply with the bracket, and also after multiplying with this second bracket, and make a quadratic equation like something plus something plus. Okay, and then with the addition property apply sigma for both side, and with the shortcut you can find the value of k is equal to 1 to 10. Okay, second question is, what is the sum of whole number from 10 to 100? Okay, they have given a summation of 10 to 100 and whole number. Okay, but how do we calculate? We know that if it is a n is equal to 1 to 100, we can find with the help of shortcut. Okay, but how do we find these types of example? It's easy. If it is a, you can see that here 10 to 100, if we take n is equal to 1 to 100 and minus from 1 to 10, so we can get the 10 to 100. Yes, summation. If we take summation of 1 to 100 and also summation of 1 to 10, we can subtract them both, so we can get the value of summation of 10 to 100. So you can use this formula to solve these two different questions. Okay, and upload it in RNWIET application. Okay, so today your lecture is completed.